Happy Carmen, and this is my Physics 2212 Lab 1 charge tape. In today's lab, we are analyzing how charges interact with each other via tape. Content in this lab include purpose, procedures, physics behind the lab, a code/computational model for the lab, error that may arise, and questions we may have. Purpose, for the purpose, we're trying to analyze how charges interact in the real world and then see how Newton and Coulomb's laws uphold within the lab, and then use those laws to find the charge on the tape. So Coulomb's law equals 1 over 4 pi epsilon times Q1 Q2 over R squared. And then Newton's law equals, second law, equals F equals ma. We know A is G. So since we're trying to find the charge on the tape, we just solve for Q, and then we get Q equals square root of mg r squared over K. K is just this constant. All right, materials needed. You need tape, meter stick, objects to support the tape, a laptop for coding, and some sort of camera to record the experiment. So instructions: get 2 pieces of tape and fold them like so. Make sure that the top tape has a handle so you can easily pull it off and on. So during each repetition of the experiment, you have to pull it off to charge the tape. And so you pull it off, put it on the edge of the table, and then we're trying to see if it's positively charged or negatively charged. So if you put your hand on it, you see that it pulls it. However, we don't know what charge our hand is. So you can find the charge by rubbing a plastic object on your hair or like on some type of wool. And then we know that negatively charged the plastic. So then if you put it close to the tape, if the tape is attracted to it, that means it's opposite charge. Therefore, the tape is positively charged. And if the tape is repelled by it, we know that it's the same charge as the plastic, so negatively charged. And we can see that it's attracted to it, so it's positively charged. The tape is positively charged. So for part 2 of this experiment, we're trying to see what the R is in our electric force. And so you have to suspend a piece of tape over 2 objects, over 2 objects, and then we're trying to see what that R is by moving the positively charged tape closer to the neutral one.
Recording again.
In this video, we can see that the tape barely moves and that the R is approximately 0.08 centimeters. That means that mg equals electric force at when R equals 0.08 centimeters. We also did this to visually see how 2 positively charged tapes interact. All right, so for the code, a lot of these things are just universal constants. Protons, yep, mass 9.8. The length of our tape was 0.02 meters. We need to do everything in terms of meters, not centimeters, so make sure to convert that all the time. And then for the mass, we were given that the density equals 1 gram per meter, so we just solved for the mass of our tape. And then the distance, our R, is 0.08 centimeters, or meters. And then everything else is just gravity in the y direction. The charge, we solved this at the beginning of the lab, and that's just this in code. These are the R vectors. We use this for the electric field, and then everything else is just printing like the forces on each other. All right, so we get that the charge on the tape is 1.66 times 10 to the negative 9th, and then the electric field is in the y direction, 2,347 Newton over coulombs. The yellow is the gravity, and then purple is the electric force. Error that may have occurred during this lab is air resistance, as we didn't account for it. We also represented the whole tape as a point charge, which is not true. And then we assumed that the charge on the tape was evenly distributed, which may also be false. Questions. What if electrons had positive charge and protons had negative charge? This wouldn't really change anything, as in physics, the main objective is understanding that opposites repel or attract, and same charges repel. So it would just like not really change anything. Why is it important to handle the charge tapes as little as possible? This is important so we make sure that the electrons don't transfer from the object to our hands and ruin the experiment. Thanks for watching.